Because we use only 3, which are length, time, and mass, doesn't mean that those are the only basic quantities. There are 7 basic quantities. But these 3 are the ones we use to obtain derived quantities. So, derived quantities are quantities which are obtained from the basic quantities of length, time, and mass. Good. Derived quantities are obtained from these 3 quantities, and we are going to see, we shall, by means of a formula, see how derived quantities are obtained from these 3 quantities. And actually, we can also note that the units of derived quantities are also derived units. And they are derived from the units of the fundamental quantities that produce them. So, the units of derived units, the units of derived quantities, are also derived. Good. Are also derived from the units. You derive a unit from a unit. Are also derived from the units of the basic quantities. Units of the basic quantities that produce them, or that derive them, that produce them. And this is a very important note. We are going to get a unit from the given units. If you know the unit of time as second, and the unit of mass as kilogram, and maybe there is a quantity which is maybe given by the formula time over mass. Even the unit of that quantity will be second over kilogram. And I shall see how we can write that unit. Second over kilogram. Maybe a quantity is time times mass. Time times mass. We shall see. We shall say second times kilogram, which is second kilogram. If it is second over kilogram, it will be second per kilogram. Per means over. That's the language we are going to use in deriving units and quantities. Yes, we are going to look at. There are very many derived quantities. We cannot look at all of them. We're going to look at some of the derived quantities with their SI units. We are going to see how we derive them together with their SI units. It will be by means of a table. This is quantity. I want to invest them in a table. This is unit quantity. Then I can talk about its dimension or expression. Dimension. This is kind of its formula. And SI units. SI unit. Let me talk about, can look at area. Area is a derived quantity. And whenever you are calculating area involves 2 lengths. Area, and that's very important, involves 2 lengths. You multiply 2 lengths whenever we are dealing with area. So, area is length times length. You will appreciate that when you reach area. It may be a half base times height, half pH. This base is the length. This height is a length. Yes. Base is a length. Maybe this is a base height. If I have a rectangle, this is base. Okay, maybe a width, or a height. Maybe a width. So with this figure has a base and a height. So you can see that this base is a length and height is a length. This is one of the formulae for area. It may be length times width. Length times width. This length is a length and width is a width. Let me use this blackboard. This blackboard has very many lengths. You see, there are different kinds of lengths. There is a length from the other corner to this corner, which we normally call length. There's a length from this corner to this corner, which you can call width, but they are both lengths. There's a length from here to here, which you call thickness or height. Area is length squared. If it's one length, it will be squared. Like there are some, it may be pi r squared. This radius is a length, and since it is one radius, that's why we square it. That's why you square it. Always area is length squared. Always area is length squared. You can't have this formula for area because these are three lengths. This is 2 and this one makes 3. That's now volume. You have left area. So whenever you see a formula of area and someone is telling you that this is a formula for a given area, even if it's talking about a figure you have never heard of, you can say no, man, this is not a formula for area. It has more than required lengths in the area. Area involves multiplication of two lengths to get length squared. And so the unit for area is the unit of length squared, meter squared. We can have volume. Volume. We call this one A, this one B. Volume. Volume. The formula for volume is volume involves multiplication of three lengths. It may not be direct like this, but it will involve three lengths which are multiplied. It may be length times width times height. These are all lengths. This duster here has a length, has a width, has a height. Height is what you can call thickness. This ruler here has a length from here to here, has a width from here to here, has a thickness, which is the thinnest, which is the shortest, from here to here. Thickness. This is the thickness. This one, from here to here, is the thickness, which I call height, or which we call height. And those are all lengths. It may be pi r squared h. This is length squared. Length squared times length to get length cubed. Three lengths. Yes, it may be a third pi r cubed. Cubed means it is r times r times r, and r is a length. Radius is a length. Maybe from the circumference to the center. It is a length. So volume involves multiplication of three lengths, and okay, I can put it in brackets, length cubed. And so this unit will be the unit of meter, now cubed. We are calling them derived units because they are derived from the units of the basic quantities that produce their quantities. This area is a derived quantity which is derived from length and length. And this unit will be meter, and meter times meter, get meter squared. When you multiply the quantity, you multiply the unit also. Meter times meter times meter. Each length is in meters. This one for that. Get meter cubed. Get meter cubed. Even if it is pi cubed, it will be pi does not have a unit. Maybe the formula is a third pi r cubed. Pi, this one does not have a unit. This one does not have a unit. R is in meters because it's the length. Now cubed. So that the final unit will be meter cubed. Volume is in meter cubed. We can have, let me give you speed. Speed. Good. Speed. We know that speed is the distance. Is distance over time. Distance over time. But distance is length. Actually, we define length, we have reached that or that, but we shall define length as the distance between the 2 points. When I say length, I can also say distance. And when I say distance, I can say length. The distance from here to here is the length from here to here. Understand that very well. So speed is distance, which distance I've said is length over time. This one scientifically is written as L. You see, scientifically, instead of saying the over, we put negative. We assign this power. This one we take it and we raise it to its negative power. Its negative power. Since this is t power and power 1. When you see that there's nothing here, it is t power 1. So we raise it to its negative power. Scientifically, this is how we write it. This one scientifically is this. If it was L over t squared, scientifically we just put a negative on this one, on the power of this one. L t power negative 2. T power negative 2. If it was maybe, we shall see that volume, we shall see maybe density is mass over volume, mass is in kilograms, over volume in cubic meters. This will be kilogram. Just put a negative on this one. Bring it and just put a negative on the power of the lower unit. So now this one can guide us. The unit of speed will be, the unit of length is meter, the unit of time is second. Power negative 1. Power negative 1. Which you can, in here, let me give you 2 options. Can give you 2 options. From here, I can say it is meter over second. That one is over. You may not do like this, but you may write it as this. This one is the same as this. But scientifically, we have said that we may write it in a linear way, or meter second power negative 1. The denominator goes, and you assign it a negative up. That is speed. I can talk about another quantity, another derived quantity, and I show you how we derive it together with this units. Density. This speed is also symbolized V. Density is symbolized rho. Write P, put a tail. Write P and put a tail. And density is the mass per unit volume. Density is equals mass over volume, and it is defined as mass per unit volume. It is not a ratio. It's not a ratio. It is mass per unit volume. So, mass, can say mass per unit volume. Now volume, that is mass. Remember, mass is one basic quantity, which we say as a dimension m. As a dimension, just one m. Then volume is length cubed. It is here. Length cubed. Volume is length cubed. This I've said, we can write it scientifically as this. This one goes up and it becomes negative. If it has been positive, it was like, if it was like this, when it goes up, it changes to a positive. Changes to a positive. So, yes, just changes the sign. Now this, if you ask me to tell you the unit of density, I will say this is mass, which is in kilogram, and this is length, meter, 30, or negative 3. Yes, or I can write it like this. Like this, it is kilogram over length. Length is in meters, because the unit for length is in meter, but cubed. It is cubed. This tube here. Good.